Today's topic is empirical formulas. We're going to learn what an empirical formula is and how to determine an empirical formula from the percent composition of a compound. So grab your calculator and a periodic table and we can begin. So let's start by talking about a molecular formula. Molecular formulas give the exact number of atoms of each element that's in a compound. An example would be C6H12O6. And if we were to look at the picture of that molecule, we can count the carbon and see that there is 1, 2, 3, 4, 5, 6 carbon. We can count the hydrogen, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And we can count the oxygen, 1, 2, 3, 4, 5, 6. The formula C6H12O6 is telling us exactly how many of each of those atoms are in the molecule. Now, an empirical formula reduces the molecular formula down to its simplest subscripts, or the lowest ratio between the elements. If we're going to take that same formula, C6H12O6, and turn it into an empirical formula, we'd want to look and see what is the biggest number that we can divide all those subscripts by and still have whole numbers when we're done. And the answer would be 6. We can divide each of those subscripts by 6. And when we divide 6 by 6, it's going to equal 1. So the carbon and the oxygen will now have subscripts of 1. And 12 divided by 6 will give hydrogen a subscript of 2. So it tells us the ratio of atoms in the compound, but it doesn't necessarily tell us the exact number of each atom in the compound. So take a look at these 4 examples, and for each one, determine if it is an empirical formula. And if it's not, see if you can identify what the empirical formula for that substance will be. Pause the video while you're thinking, and when you're ready, start the video up again. Okay, so let's see what you came up with. If we look at H2SO4, that is an empirical formula because we can't simplify it any farther because the sulfur doesn't have a subscript shown, so it's understood to be 1, and we can't simplify lower than 1 and still have whole numbers. If we look at example B, that is not an empirical formula because they're all even subscripts, so we can divide them all by 2, and that would give us the formula of P2O5. C is also not an empirical formula because, again, they're all even numbers, which means they can all be divided by 2, and the empirical formula for N2F4 would be NF2. And then the last example, N2O5, that one is an empirical formula because there isn't a number we can divide both 2 and 5 by and get smaller whole number ratios. So let's see if we can find an empirical formula for a compound based on the percent composition of the elements that are in the compound. What is the empirical formula for a compound that is 50% sulfur and 50% oxygen? Well, our first step is going to be to change the percentages to grams so that we can convert to moles. So that's going to be step 1. So how do we go about changing percentages to grams? Well, if we had a 100-gram sample and 50% of it is sulfur, 50% of 100 grams would be 50 grams. So if we assume we have a 100-gram sample, we can just swap the percent sign with the gram sign. So we're going to start our work by trying to convert 50.0 grams of sulfur to moles. So we're starting with 50.0 grams. We need to get rid of grams using dimensional analysis. So we're going to put the molar mass in the denominator. So when we look up sulfur on the periodic table, its molar mass is 32.06 grams. That's equal to 1 mole. So we would cross out the grams, multiply across the top, divide by the bottom, and that comes out to be 1.56 moles. We're going to do the same thing for oxygen. And again, since it's 50% oxygen, we're going to change that to 50 grams of oxygen. We're going to do a mole conversion, The molar mass of oxygen off the periodic table is 16.00, and that's equal to 1 mole. And that comes out to be 3.13 moles. Now we're going to use the mole amounts to determine the smallest subscript. And we do that by dividing both moles by the lowest mole number, which in this case is 1.56. 1.56 divided by itself is 1, and 3.13 divided by 1.56 is going to be 2.002. And the 2.002 is not a whole number, but looking at that number, we can say that that's equal to 2 because you go out to the thousands place before it's not exactly 2. Now we have the subscripts for our empirical formula. The S should have a subscript of 1. And of course, a subscript of 1 we don't need to write. And the oxygen should have a subscript of 2. So the empirical formula is SO2 when we have 50% sulfur and 50% oxygen in the compound. So let's try another practice problem. What is the empirical formula for a compound that is 75% carbon and 25% hydrogen? So remember, step 1 is we're going to change the percent to grams and determine the number of moles for both carbon and hydrogen. So I'm going to write that out. I'm going to make sure I label my work so I don't get confused later on. We need to divide by the molar mass. We're going to set that up in our conversion problem. 1 mole of carbon is equal to 12.01 grams. We're going to be left with 6.24 moles. We're going to do the same thing for hydrogen. Hydrogen's percentage is 25.0. We're going to change that to 25.0 grams. We're going to set up a conversion factor where 1 mole is over the molar mass of hydrogen, 1.01 grams. Going to divide, and we get an answer of 24.8 moles of hydrogen. So remember, step 2 is we're going to take those moles and find the lowest subscripts by dividing both moles by the smallest number. And in this case, the smallest one is 6.24. So 6.24 divided by itself is 1. 24.8 divided by 6.24 is going to equal 3.97. And again, we're going to say that 3.97 is almost equal to 4. It's close enough to 4 that we can round up because it's only 3/100ths away from 4. So those are going to be our subscripts. The subscript for carbon should be a 1, and the subscript for hydrogen should be a 4. And we're going to use those to come up with our empirical formula. So carbon is going to have a subscript of 1, which we don't need to write, and hydrogen will have a subscript of 4. Why don't we take a look at this practice problem? What is the empirical formula for a compound that is 69.5% iron and 30.5% oxygen? Remember, our first step is to change the percentages to grams and then convert to moles. So we're going to figure out the moles of iron, assuming we have 69.5 grams of iron. We're going to say that 1 mole of iron is equal to its molar mass. The molar mass on the periodic table is 55.85. Grams are going to go in the denominator, so they cancel out. 1 mole will go in the numerator, and we're going to be dividing 69.5 by 55.85, and that comes out to be 1.24 moles. Looking at the oxygen, we're going to change 30.5% to 30.5 grams, and then we're going to put 1 mole over oxygen's molar mass, which is 16.0, and we see we need to divide 30.5 by 16. That comes out to be 1.91. And now we need to divide both numbers by the lowest one, which in this case is 1.24. So 1.24 divided by itself is 1. And 1.91 divided by 1.24 is going to give us 1.54. So 1.54 is about halfway between 1 and 2. We really can't say that it's very close to 1, and we can't say it's very close to 2 either. So in this case, we can't just round this to 2. we're going to have to come up with a number that we can multiply by that will change this to a whole number. And if we look at the 1.54, our remainder there is a half. And we need 2 halves to make 1 whole. So we're going to want to multiply the 1.54 by 2, and that's going to bring us closer to a whole number. So 1.45 times 2 is going to give us 3.06, and that we can say is equal to 3 because it's only 6/100ths away from being 3. Now, if I multiply one of them, I got to multiply the other moles as well. So when I write my empirical formula, the irons should have a subscript of 2, and the oxygen should have a subscript of 3. So after dividing, if any of the subscripts end in 0.25 or very close to it, it could be 0.23, 0.27, 0.28, we're going to say that that's a quarter. And you need 4 quarters to make 1 whole. So anytime it ends in 0.25, we're going to want to multiply that by 4 to get a whole number. Or after dividing, if we end up with a remainder of 0.33, that would be 1/3. You need 3/3 to equal 1 whole. So we would want to multiply that by 3. And as we saw in the last problem, if it comes out to be 0.5 or very close to it, we need 2 halves to equal 1 whole. So we would want to multiply everything by 2. So we're going to try one more problem before we leave. What is the empirical formula for a compound that is 57.45% carbon and 3.45% hydrogen and 39.01% fluorine? So here's an example that doesn't have just 2 elements, it has 3, but we solve it the same way. First thing we do is change the percentages to grams and then convert from grams to moles using the molar mass of the element. All right, so carbon's percentage is 57.45, so that would be 57.45 grams. We need to look up the molar mass of carbon on the periodic table. It's 12.01. So that goes in the denominator, 1 mole goes in the numerator, and we have 57.5 divided by 12, which comes out to be 4.78 moles. Now let's tackle hydrogen. Hydrogen's percentage is 3.45. We're going to change that then to 3.5 grams. We need to come up with a conversion factor that goes from grams to moles. So that's the molar mass of hydrogen off the periodic table in the denominator, 1 mole in the numerator. We multiply across the top, divide by the bottom, and we have 3.41 moles of hydrogen. For the fluorine, we're going to change 39.01% to 39.01 grams. We need to convert from grams to moles using our conversion factor, where the molar mass of fluorine, 19.00 grams, goes in the denominator, 1 mole in the numerator. We multiply across the top, divide by the bottom, so 39.01 divided by 19 is going to be 2.05 moles. All right. Now we take all of these numbers and divide each one by the smallest number, which in this case is 2.05. So 4.78 divided by 2.05 is 2.33. 3.41 divided by 2.05 is 1.67, and 2.05 divided by itself is 1. So if we look at 2.33, it's not really that close to 2, and it's not close to 3 either. We can't round. The remainder is 1/3. So we need 3/3 in order to equal 1. So we're going to multiply 2.33 by 3. And that comes out to be 6.99, which we can round to 7 because it is practically 7. It's off by 1/100th. Whatever we multiply one of the numbers by, we need to multiply each of them by. So 1.67 will also get multiplied by 3. And that comes out to be 4.98, which again, we can round to 5 because it's almost 5. It's very, very close. It's off by 2/100ths. And then we also need to multiply the 1 by 3, and that's going to come out to a whole number 3. So when I need to come up with my empirical formula, I need to look at each of the elements from my clearly labeled work so I don't get confused. I can see that the carbon should have a subscript of 7. The hydrogen should have a subscript of 5, and the fluorine should have a subscript of 3. And there's my empirical formula for this problem, C7H5F3. Thank you so much for joining me for this empirical formula lesson, and I hope to see you soon.